X or B both in Rn. So A is n by n. Okay? N1 notation you used in your homework. No reason you shouldn't have, because I hadn't introduced standard notation. You indicated an n by n matrix by doing a capital A with a subscript n by n. Okay? Don't do that, because that's easy to confuse with the subscript notation I showed you last time for a matrix.
Okay.
Okay? So that's something you want to avoid. It was fine when you did it. You didn't know any better. It's not standard notation. And you'll see more standard notation as you start reading the book. Okay, so A is n by n. Okay? If A reduces to the identity, possible to find A inverse. Well, when you multiply an inverse by something, you get the identity. Okay? Or just X equals A inverse B. Okay? If these were algebraic, if these were just numbers, well, A to the negative 1 is 1 over A. You multiply that by A, you get 1, and that's how you solve the equation, right? So this is totally analogous to how you solve an equation with numbers. If you have 2x equal 3, multiply both sides by 2 to the negative 1, right? And you get 1x equals 2 to the negative 1 times 3, or x equals 1/2 times 3 equals 3/2. That's actually what's going on algebraically. But you just used to do it by numbers, and that's the way we learn it. We learn algebra. We're generalizing it. Okay? If you have 0x equals 3, there's no inverse for 0. Okay? Similarly, there's no inverse for a matrix that doesn't reduce to the identity. It's actually pretty easy to see why. You'll probably see it. I want to show you how to get the inverse first. Okay? Simple mechanical process, just row reduction. Okay? So, you just reduce the matrix you get if you have the A matrix here and the I here. Okay? 2. Well, you reduce A down to I. Okay? And whatever I reduces to in the same process is A inverse. Okay? So for example, let A equal 2, 3, 1, 5. Clearly that's going to reduce to the identity because one row is not a multiple of the other. More complicated, of course, you have more than one if n is bigger than 2. So, it's just an augmented matrix, but you're augmenting A by the entire identity matrix. Okay? Well, okay. So we got take half of the first row. Okay? Add negative first row to the second. Okay? Got this, right? If I did that right. Yeah. Have a crapshoot here. Okay. Then multiply this row by 2/7. Okay? And you get this. Then add negative 3/2 of this row to this row. It gives you the identity here, and if I've done everything right, or if I managed to do the last step correctly, okay? Well, negative 3/2 of negative 1/7 is negative 3/14, right? And add that to 1/2, which is 7/14, you get 4/14. I'm doing this quick, we'll check, because typically you screw it up if you do it in your head. We'll see if I did or not. Okay, now let's keep my wits about me here. We're going to add negative 3/2 of this to this. Well, negative 3/2 of this is negative negative 3/7. Okay, so we get negative 3/7 here, negative 1/7, 2/7. Okay, now let's test this. First of all, does this multiplied by this equal the identity? Because that's so, okay? So, okay? We get this. Well, 2 times 4 is 8. 3 times negative 3 is, okay, well, we're going to have to add these. So 3 times negative 3 is negative 9, so we get negative 9/7, which is negative 18/14, right? And we've got 8/14 here. So it looks like we have a mistake. Something's wrong here, so we've got to go back and check it. Okay? Because I think we're getting negative 18/14 and 8/14 when we should be getting 14/14, because this should be the identity. So something's messed up. And I don't know what step I messed up, probably. Okay. Negative 3/2 of this is 3/14. I think I said negative 3/14, so I got my negatives messed up. And that would be 7/14. Okay? So this should be 10/14. So let's fix that. Now, still that's no good. Okay, 20/14, so we've got 5/7 and negative 9/7. not add up to what it should add up to. 3/2 or 2/3, 2/7 is 3/7, and the negative of that's -3/7. So something else got messed up. So I did this in my head, did it carefully, it works out. So we messed up the reduction. Okay? So my mental arithmetic is screwed up. Not often. I mean, not rare. Nothing rare about that. Okay, so let's just check this if I can spot it. I can't do it in a minute. Forget it. Okay, so that's right. It's not that hard. I'm not seeing anything. Oh. I did. No, it should be -3 actually. Looks okay to me, but it isn't. That should be 10/14 because that's 1/2. I was treating that like 1. That'd be 5. It'd be 7/14. And no, that comes out 10. Seems pretty obvious, but okay. Anyhow, you get the idea. So that's how you get an inverse matrix. If you get the right inverse matrix, then you can solve this equation just by multiplying the inverse matrix by your B vector. Okay? And that can be a big deal. And inverse matrices have a whole lot more to them than that. Okay? They're elementary matrices, which we'll probably talk about next time, because it's really neat what you can do with them. But it's a simple mechanical process. For any matrix, you just reduce. You augment the matrix by the identity, reduce the left side down to the identity, and you get the inverse. Okay? Okay. And of course, to do that, the matrix has to reduce to the identity. It has to be invertible. Okay? And there are a lot of connections there. Make sense? Okay. I'll ask you to calculate a couple. I'll ask you to do this one right, find my mistake. Then I'll give you probably 3 by 3 just to practice on. Okay?